We are talking about the concept of box plot. So the main reason of using box plot is for identifying the outliers. Okay, we'll be talking about outliers in the next video, but the concept is quite simple. If you talk about the word itself, you can divide it into two: outliers. So these are going to be the data points that are lying outside of a given range, outside of a defined range, right? So let's talk about box plot now. So if you have a given data set, in this case I am taking even number of data points in this data set. In the next video we will be talking about odd number of data points as well. So suppose this is our data set. It's okay if your data set has repeated values. You just need to make sure that all of your data points are arranged in ascending order. If they are not sorted, then your first step is going to sort them out. Okay, so now that we have our data set, what we can do is we can identify the minimum value and the maximum value from this range. So the minimum value over here is 10 and the maximum is 22. Next up, we are going to be finding median, which here can also be represented as quartile 2. So that is, we are representing it with a Q2 here. So 12 and 13 here, these two are the values. Because this is even, we are getting these two values here. So I'm just going to be adding them up and dividing them by 2. So the answer is going to be 12.5. So 12.5 is our median. Now we have to find Q1 and Q3 as well. So what I do over here is I'm going to be dividing the data set from here into two equal parts. Now we are going to be finding the median for this range here. So this range happens to be the lower part of the median and these here are the higher or the upper part. Okay, so if we had to find median for these, so that's going to be, we are just going to strike out. Okay, so 11 plus 11 divided by 2, it's going to give me 11 itself. And if we work over here and 22, 13, 17, 14, so we have 14 plus 15 divided by 2, which is going to give us a 14.5. So now that we have all of these values, this is quartile 1, quartile 2 and quartile 3, we are going to start plotting the box plot now. So if this is my horizontal axis, I have 10, 11, 22 here. So here it is, let's say 12.5. okay, not that visible, 12.5, and somewhere over here it is 14.5. so my Q2 is 12.5 and my Q1 was 11, my Q3 was 14.5. so I'm just making a box. So for your box plot, the box is going to be made on these three data points only. So your Q2, which is 12.5, it would be making, either you can make a broken line or a straight line, does not really matter. So this is your Q2, this is Q1, and this is your Q3, right? So all of these three are constituents for making your box, and your minimum and maximum, that here in this case is 10 and your 22, they are going to be making the head and the tail of your box plot. Okay, once we are done, this actually completes your box plot. But the questions that are asked generally, because this question comes for 5 marks, they'll ask you to plot the graph, they'll ask you to find the interquartile range and the higher outlier value and the lower outlier value also. Your interquartile range is going to be this range here. So between your 14.5 and 11, this 3.5 value that you get is this part here, right? The entire value is of 3.5. Next, the higher outlier. So the higher outlier is, formula for that is Q3 plus 1.5 into your interquartile range. So 1.5 is already predetermined, we cannot really make any changes there. So that is going to be your 14.5 plus 1.5 into 3.5. So the answer here comes out to be 19.75. So this higher outlier, or this 19.75, means that in your data set, if you have any value which is greater than your 19.75, then that value goes becoming a outlier. So here in this case your 22 becomes an outlier. Okay, so now we move forward, find the lower outlier value as well. So that is going to be Q1 minus 1.5 into your interquartile range. So that is going to be 11 minus 1.5 into 3.5. So this is going to give you 11 minus 5.25, which gives you a 5.75. So now this value means that if in your data set you have, here we don't, but if in the data set suppose we had a 1, so 1 would become an outlier because it is less than your 5.75. That is it for this video. In the next video, we are going to be covering a question where the data set contains odd numbers of data points, just so that we get an idea about how to deal with a question where you have odd number of data points. That is it. Bye.